This is problem 1-17, it's on page 15. Determine the mass in kilograms of an object that has a weight of A, 20 millinewtons, B, 150 kilonewtons, and C, 60 meganewtons. Express the answer to three significant figures. I suppose they mean for each one. So let's start off with A. They told us that the weight of an object was 20 millinewtons, so that's the weight. But of course, we know that weight is mass multiplied by acceleration. So if we want the mass of the object, what we will have to do is take the weight and divide it by the acceleration of gravity. So in this case, we've got 20. Now, milli is 10 to the negative third, so 20 times 10 to the negative third, and those, of course, are newtons. Okay, so the 10 to the negative third is from the milli, and then I just copied down the newtons. And then g, the acceleration of gravity, is 9.81 meters per second squared. Now, a newton, we could get rid of that in favor of kilograms meters per second squared, because that's the same thing, and then the meters per second squared would cross off, and you'd see that we're left with kilograms. Now, of course, 10 to the third, or 10 to the negative third, and k, which is 10 to the third, would cancel. And so all we've got to do is take 20 divided by 9.81, which is going to be about 2. Turns out that number is 2.04, and the units then would just be grams. Now that may not be the preferred answer. You may want your answer in kilograms. If so, just move the decimal place 3 places to the left and call it out. So it's about 0.002 kilograms or so, 2/1000ths of a kilogram. Part B, the question was, if we have an object that weighs 150 kilonewtons, obviously we're assuming that this is on Earth, then calculate the mass. Nothing has changed in our approach. All we have to do is take the weight, 150 kilonewtons, and divide it by 9.81 meters per second squared. Now things are a little bit different. I'm going to take the newtons themselves, not the kilo, but the newtons, and convert them to kilograms, or to convert it to kilograms meters per second squared. Now, this kilo here is not this kilo. They're two different ones. A kilonewton is 1,000 kilogram meter per second squared. Again, this allows the meters per second squared to cross off nicely, and we're left, once you take 150 divided by 9.81, you've got 15.2 numerically, and that is kilograms. Now, that's not good practice. You don't want compound prefixes. That's not a good idea. So I just went ahead and realized this is 1,000 and wrote 15,200 or so, because I'd already rounded off, trying to observe significant figures, kilograms. So there is what I would write as my answer for part B. Part C says if the weight is 60 meganewtons, then how much mass are we talking about? Well, let's see, 60 meganewtons. Again, newtons are kilograms meters per second squared, so that when we write 9.81 meters per second squared, they can cross off nicely. And plug in the numbers into the calculator. 6 over 9.81 is 6.12 mega kilograms. Again, not good to have a compound prefix. I realize that mega is 10 to the 6th, and kilo is 10 to the 3rd. Add the exponents, that's 10 to the 9th, and the proper prefix for that is giga. So this is 6.12 gigagrams, if you like. Now you could do other things. For example, you could say that this is 6.12 times 10 to the 6th kilograms. Since kilograms are the standard unit of mass for SI units, then this is fine too. Depends on the context and what you're doing with it. But either one of these would be okay.